official today. So we've looked at 7 and 8. You guys did awesome on that quiz, so I have no concerns there. So looking at chapter 9, we're going to be doing confidence intervals now, and looking at what that means. Okay, so to start with, here's a question that's really kind of a review. So if we had a poll that asked 1,783 registered voters if they favored or opposed the death penalty for persons convicted of murder, 1,123 were in favor. Find the point estimate for the proportion who were in favor of the death penalty. So when I ask for a point estimate, what am I asking for? What variable do we call that? P hat. And P hat we know is x over n. So we get what? So, question, does this mean that most people favor the death penalty? So we're getting 62.98%. Does that mean most people favor it? In that sample, what about nationwide? Is that enough to convince you that most people do nationwide? Not necessarily. If we got a different sample, would we have a different percentage? Yes. So the question is then, how confident are you in our estimate? So we know that the total population probably doesn't match. The sample, if I got a different sample, it probably doesn't match. And that's what we talked about in the last section when we looked at the pumpkins and we talked about getting all those different samples. But there is a question of how confident are you? If you look at like around election time, the news is covered in polls, and then this poll, this candidate is in favor, and then at the bottom it'll have like a margin of error. That's kind of this confidence thing. So that's what we're going to look at. How confident can we be? Because we know that that's probably not the true value, but maybe I could give a window of values. Maybe I could say I'm 90% confident it's between 60 and 65%. That's where we want to be able to go with this. So the confidence interval for an unknown parameter is an interval of numbers based on the point estimate. So the confidence interval is going to kind of be built around that point estimate, the p hat. The level of confidence gives us the expected proportion of intervals that would contain the parameter if a large number of different samples were obtained. Okay, which doesn't really make a whole lot of sense, but if we look here, it kind of explains it more. A 95% confidence level means that if I had 100 different intervals, 95 of them would contain the true value. So you can think of it as how if we're 95% confident it's in here, or if I had 100 intervals, 95 of them would contain the true value. So, point estimates, they're based off that, they're used to make a confidence interval, so you're basically taking that p hat plus and minus a margin of error. The margin of error is basically how accurate we are. So we're going to create a window of values. The center is our guess, which is like that p hat value. And then we'll basically add or subtract a margin of error to get this. What do you think would happen if I'm going to increase my confidence level? Would my interval get bigger or smaller? Would it? So if I want to say, I'm 90% confident it falls between these values. If I want to go to 99% confident, would I shrink it and say, I'm 99% confident it's between 60 and 61? Or would I say I'm 99% confident it's between 50 and 70? Yeah, we'd probably go bigger. So the bigger we get, that's the higher the confidence. A smaller window is a lower confidence. Because if the window is very small, it's more likely that we will miss the number we need. That margin of error is really based on three different things. The level of confidence. So we know if we want to be more confident, we have to increase that margin of error. We have to have a larger window. The sample size. We've seen before. Is a small sample going to be very accurate? No, but the bigger the sample, the more accurate it will be. So a larger sample would decrease that margin of error. Also, standard deviation. Standard deviation is how spread out your data is. So if our data is really spread out, we're going to have to have a pretty big confidence interval to catch all the data. If our data is in a very small, tight window, then we can do a smaller level or a smaller window to catch it all. All right, so all of this is dealing with p-hats. So the things that we need to remember for a p-hat, what are my criteria? So the sample is less than or equal to 5% of the total population, and so those are the two criteria we need. When we're talking about p-hat, the mean for the p-hats is p, the proportion given in the problem. Standard deviation for p-hat is the square root of p times 1 minus p over n.
For that guess thing on the line, would you have a higher confidence if there's like less?
So when we're trying to make a window of values, think of it like if I'm giving a test, okay? And I said, all right, I am 75% confident you will get between an 80 and an 85. If I want to increase my confidence, so if I want to go to 99% confident, is it likely that everybody's going to fall in that 80 to 85 window anymore? No. So if I want 99% of my people to fall in the window I'm giving, I'm going to have to make my window wider. Does that make sense? Think of it in terms of like catching, like the first one would say 75% of my students would get somewhere between an 80 and an 85. But if I want 99% of my students, I'm probably going to have a bigger window because the more students, the more spread out those scores would be. All right, so the formulas for this are on your formula sheet under chapter 9. It gives them together, so this is a lower and an upper. Your formula sheet says plus or minus. So the minus gives you the smaller value and the plus gives you the upper. These are all things we've seen before. P-hat, this is this p-hat, 1 minus p-hat over n, we can calculate that. The only thing we haven't looked at in a little bit is z alpha over 2. We talked about z alphas at the beginning in chapter 7. Remember, z alpha is kind of the opposite of what we think. The table gives us area to the right, Z alpha is area to the left. So that Z alpha over 2 we'll have to be a little bit careful with. It has to be the case that our criteria for p hat are satisfied in order to do this. So if I were going to interpret this, what it means, we would say we are whatever percent confident the true value is between the lower and upper limit. That margin of error is how far you are from the p hat. So sometimes I'll just ask what's the margin of error, and that's the Z alpha over 2 times the square root of p hat 1 minus p hat over n. So it's basically your point estimate plus and minus some margin of error. Questions there? So let's actually look at an example. Everything makes more sense when we have a problem to do. So we're back to the same question with the poll, except now I'm asking you to get a 90% confidence interval for the proportion of registered voters who are in favor. Because we know that p hat is probably not accurate. Okay, but I want to be 90% confident the value is really between this and this. So to do that, we have to have p hat, which we know x over n. All right, we have to check the criteria for p hat, same as we were doing on the quiz. So my sample, would 1,783 be less than 5% of the entire population? Yeah. I don't know what the whole population is, but we do know we're talking nationwide, so that would definitely be the case. And we have to check the n times p times 1 minus p. So that's definitely greater than 10, so we're good. Alright. So criteria are met. The next thing that we will need is the Z alpha over 2 for the formula. And we have to kind of think about that. We want a 90% confidence interval. So it's essentially 90% of the data has to fall in here. So we have 10% left, but how much would go on each end? 5%. That's the alpha over 2. All right, we need the Z value. So it's basically the Z where you would have 5% to the right, or since the table gives us to the left, that means 95% to the left. So we are looking in our table to find 0.95. and then give us the z that corresponds to that. So in the table, the closest we can get, we have a 0.9495 and a 0.9505. So it would be right in the middle.
1.645.
Does everyone understand how I looked that up from the table? If you look, the bottom left-hand corner gives you 4 common intervals, the z alpha over 2 that match them. So we are building a 90% confidence, and it tells us the z alpha over 2 is 1.645 on our table. But you need to know how to get it from the table because there's no guarantee that I'm only going to ask for one of those 4 confidence levels. Okay. So now, it's just a matter of doing our formula. So, I want my lower limit. Formula from my formula sheet is p hat minus z alpha over 2 times the square root of p hat 1 minus p hat over n. So if I plug that in, how do we do the upper?
Just add the z.
Yeah, same thing except it's a plus in the middle. If you just hit second enter on your calculator, it brings it all back. And all you have to do is change that minus to a plus.
I don't like that we right-handed on the
I'm in the majority of things.
No.
I would do that.
That's not gonna be an intelligent thing here.
Did you guys get it?
It doesn't make it work.
So our actual confidence interval I think, did I give you guys a blank slide after this too?
Yep.
Okay. So what that means, that's probably the hardest thing about confidence intervals is kind of understanding what it means. It's saying this was a 90% confidence interval. So we are 90% confident. Or if we did 100 trials, 90 of those 100 times, the true value is between 0.6110 and the 0.6486. So the next one I just want to interpret. So why don't you guys take a second, read this, and see if you can figure out what the confidence interval would be. We know 54.9% think it's fair. And this is how they said. They did a random sample of 1,016 national adults. They are 95% confident that the maximum margin of sampling error is 4 percentage points. So they estimated it at 54.9%. If that margin of error is 4%, can you tell me what your confidence interval would be?
Oh,
What would 4% less than
50.9.
and 4% higher? So you can give them as percents. Normally with p-hats we do the decimal form, which is fine. So it means we are 95% confident. The proportion is between, I'm going to say 0.509 and 0.589 because it's a proportion, or you could say the percent is between 50.9% and 58.9%. Questions here? Let's do another. We're going to make a confidence interval this time. So, a survey asked 800 16 to 17-year-olds in the U.S. if they had ever used their cell phone to text while driving. Of these, 272 indicated they have. Obtained a 95% confidence interval. What do we need if we want to build a confidence interval? How do we get p-hat? And we get a p-hat of 0.34. What do we need next?
Criteria.
Criteria. What are the criteria when we're dealing with p-hat? So would 800 be less than 5% of all 16 to 17-year-olds in the U.S.?
No.
Okay, and we need to check if n times p times 1 minus p is greater than or equal to 10. And we get 179.5, so that's definitely true. Alright, now what? Okay. This is one of the common percents where it's given to us, but let's see if we can figure it out. If 95% is in the middle, that means we have 5% left to split over the two ends. So each end gets 0.025. If I am going to look it up in my table, the table gives us everything less than. So what probability do I need to look up? 0.975. So we look up 0.975 and it is on there exactly 1.96. Double check the bottom left of that table. Is that the Z alpha over 2 it told us for 95%? Yep. Okay. Now we do our formula. You don't necessarily have to label it as a lower and upper. If it's easier, you are welcome to set it up like the formula sheet has. So it's our p hat. We're going to do plus and minus our z alpha over 2 times the square root of p times 1 minus p over n. So we just put in the minus 1 and then we'll come back and do the plus, and that will give us our window. always hit that. Sometimes 3 to 4 decimal places is good on the confidence interval. It kind of varies what the standard is, but either 3 or 4 is good for me. So if I ask you to interpret it, what does that mean? Exactly. We are 95% confident. The true proportion of 16 to 7-year-olds who have texted while driving is between this value. Okay. So, do you want to learn how to do it on our calculator without doing the whole thing by hand?
Absolutely.
All right, let's try it. So, I want to see what happens if we change that margin of error to 99%. So the one we just got for 95%. I'm just going to copy this down so I have it on the same slide. What was it? Point. Thank you. Comma, point.
372.
So we want to see what the 99% gives us. So we can redo the whole thing. The only piece that changes is the z alpha over 2. It is also very easy to do these on your calculator. So, on the calculator, you want to go to Stat, Tests, and then we need to go down, and we want letter A, which is a 1 proportion, because we have 1 p hat, z interval. Okay, so the 1 proportion z interval comes up. And it asks 3 things. X and C level. So what was my X? That's from our p hat. Let me get X over N.
272.
My N. Okay. For fun, let's do the 95% confidence level first and see if we get the same answer we did by hand. So it gives us 0.30717 and 0.37283. So that matches. Okay, repeat, stat, tests, go down to A. My X and N are the same, but this time I'm going to change my confidence level to 99. And it gives me 0.2969 and 0.3831. So think about what happened here. The original 95 started at 0.3072 and ended at 0.3728. This was my original interval, 95%. When I did 99%, it dropped down 0.29 and went up to 0.38. So we can see that 99% got wider. The higher your confidence level, the bigger your interval is going to have to be. Is that okay? I know I'm talking a lot today, but let me get through the last couple slides in case I'm not in here tomorrow. So, if I asked you to find the point estimate of the population proportion, so we're finding the point estimate, that means I'm looking for p hat. The margin of error, so I need the error, which is sometimes is called E, and the number of individuals in the sample. And this is what I'm giving you. Oh, sorry, not the number, total number. I need the number with characteristic X. I gave you N, we're looking for X. Alright, so think about how a confidence interval is found. We have the lower and upper. What's in the middle? That's our p hat. Can we find the middle of this? Yep. Add them up, divide by 2. And so my p hat is 0.0625. Your margin of error is how far it is from your p hat to either the upper or lower limits. So all we have to do is p hat and subtract one of those. So if I did my p hat 0.0625, subtract my lower limit, I get 0.0115. So that's my error. That's what I have to add and subtract from my p hat to get my limits. Does everyone see where I got that? So basically your p hat minus the error gives you the lower limit. So I did 0.0625. I don't know my error, but I know my lower limit. And so it's just basically taking that formula and solving for what I need. To get my x, we know that p hat is x over n. But I know my p hat. I'm looking for x, but I know my n. So if I multiply over the 1,120, it's 70 for my x value. Is that okay? So we are just going to do one last example, talking about how big of a sample do we need for something. So if there is a formula for deciding how big your sample needs to be, we don't really know how, or have to know where it came from, but we should know what all these variables stand for. We know what a p hat is, we know what a z alpha over 2 is, the e is the error. So we would just always round up because n is the number in the sample, so you can't have a decimal. Okay. This is what we would do if we knew a point estimate, a p hat. This is what we use if we don't have that p hat to begin with. So we're just going to take an example, and this is our final one for today. So sociologists wants to determine the percentage of residents in America that only speak English at home. What sample size should be obtained if she wishes her estimate to be within 3 percentage points with 90% confidence, assuming she uses an estimate obtained from a census in 2000 of 82.4%. So we are trying to find out how big her sample should be. And we have a prior point estimate, so we're using this formula. So p hat is what? C alpha over 2. Okay, we can use that. We also know 90% confidence. That is one of the ones that's given on the bottom of your formula sheet. So that z value is 1.645. How much error do we have? Yep, so 3 percentage points. So the error is 0.03. So we'll just plug it in. So this basically comes from taking that confidence interval formula and solving for n. So we're trying to find how many people she must survey. Okay, we know we can't have a decimal here. So if she just surveyed 436 people, is that enough? No, so you always round up. She needs 437 people to be able to get the confidence level she needs. Those okay with that one? I'm gonna throw one more thing in here. Let's do part B. What if I don't use the prior estimate? So maybe I decide 2000 was too long ago. I don't want to use that. So then we have to use the other formula. And we already have all the stuff. So we do 0.25. Z off over 2, that was 1.645. Over the error was 0.03 squared. So in this case, you would need 752 people. Okay, I know that was long today. Tomorrow's piece is shorter, and then we will have a work day Wednesday. So I do have, just like I've done the last 2 chapters, I have a packet, chapter 9 work broken into each section, but it won't be due until Thursday.